And so we're going to start with number 1. And a lot of these are more simple. But like number 1, you have 1 yard is equal to 3 feet. So that's your equality right there. And then it asks how many feet are in a football field, which is 100 yards. So what you're going to start with is 100 yards. Okay? All right. Now, my equality is the very first sentence. 1 yard is equal to 3 feet. Okay, so it says how many feet are in a football field. All right, so what is going to go on the bottom? Feet or yards? Yards. Okay, so 1 yard is equal to 3 feet. All right, and so here we're multiplying 100 times 3. You can divide it by 1, but like I said, it's not going to change the value of the number. And that's going to give you 300 feet. All right, that is your answer. And if you want to like box that in or circle it, okay, that would be great. All right, number 2. Number 2 says 1 gallon is equal to 4 quarts. That's your equality. Okay, it says how many gallons do you have if you have 18 quarts? So we are going to start with 18 quarts. All right, and I'm going to show you just kind of a different way of setting this up. It's not really a different way of setting it up. It's just a different format, but the process is still the same. So instead of setting it up like this, normally I do not use like the multiplication sign in between. Normally what I will do is set it up like this. It's the same thing, okay, literally. It's just sometimes it's a little easier to kind of visualize this. We call this, there's several names for it. You can call it train tracks, you can call it the fence post method, whatever you want. But this is basically equal to this. Okay, so you got your fractions right here, and then this line basically separates the two, and that's your multiplication sign essentially. So right here, you're going to have your equality where 1 gallon is equal to 4 quarts. What's going to go on bottom, gallons or quarts? Quarts, because quarts is on the top right here, so you want quarts on the bottom over here. So 1 gallon is equal to 4 quarts. It's kind of tight right there, but. All right, then you can go ahead and do your math. And if we take 18, the 1's not going to change the value. So 18 times 1. Divide that by 4, and you're going to get 4.5 gallons. So quarts cancels, you're left with gallons. All right, number 3. This is a metric conversion. So remember how we just looked at metric conversions by moving the decimal? You're not always going to be allowed to do that, okay? On your lab, really all of those are metric conversions. However, it asks you to solve for those conversions using dimensional analysis, not moving the decimal. So you need to make sure that you show this process. Well, this is how you're going to do it. So number 3 says how many milliliters are in 5.7 liters. You're going to start with 5.7 liters. Now, how many milliliters are in a liter? Anybody know? Peyton? Say that louder. There are 1,000, okay? So if you were unsure, this is how you would do this. I would just go ahead and write out my ladder. King Henry died by drinking chocolate milk. And I would go from milli to liter. This is 10, 100, 1,000. So every move in one direction is a factor of 10. So you move 3 places. So there's 1,000 milliliters in a liter. Now, what goes on the bottom? Liters or milliliters? Liters. Okay, so 1 liter is equal to 1,000 milliliters. And then we multiply 5.7 times 1,000. That's going to give you 5,700 milliliters. Liters cancels out. That's your final answer. Anybody not with me? All right. Look at number 4. So number 4 says the average age of a high school junior is 16.5. That'd be years. How many days old is the average high school junior? Well, you're going to start with the 16.5. And we want to go from years to days. So we know that there's 365 days in a year. What's going to go on the bottom here? Years. So 1 year is 365 days. If you multiply those together, 16.5 times 365. So that's 6,022.5 days. Okay? Years will cancel out. So 2 years from now, when you all are juniors, you will, on average, be 6,022.5 days old. You think? It is big. All right. Now, number 5. So, Peyton, you asked earlier, why do we have to worry about the ones on the bottom? Okay, so this is an example where you're using an equality where neither the top nor the bottom is a 1. Okay, so it says 16 grams of food contains 130 calories. That is your equality. 16 grams equals 130 calories. This says how many grams of food would you need in order to consume 2,150 calories. So you're going to start with 2,150 calories. And this is a general statement. I'm sure this is like an average because not every gram of food has the same number of calories in it. But 2,150 calories is what you're starting with. And then you have 16 grams of food equals 130 calories. So what's going to go on the bottom? Grams or calories? Calories. All right, very good. So we have 130 calories, which is equal to 16.0 grams. So that's one where both the numbers are non-ones, okay? So right here, we have 2,150, and you have to multiply by 16, and then I'll just go ahead and hit enter, and then go ahead and divide that answer by 130. And when you get that, you get a rather large number, 264.6153,846 grams. Now, let's just take a second and talk about how many digits you're allowed to keep here, okay? Because, we've looked at multiplication and it's the least number of sig figs and all that. This is a little different here because remember back to when we talked about our sig fig rules, I said there were two cases where you had an unlimited number of sig figs. One was counted items. The other was when you have equalities. Well, look, this is an equality right here. You're not limited in your sig figs by this at all. The only thing you're limited by is your original measurement, which was 2,150 calories. So you want to keep 3 sig figs because this is 3 sig figs. So technically, this would round to 265 grams. Okay. Zoe, you have a question?
I was just going to say, can you skip your pig driver a little while?
Oh, yeah. Sorry. All right. Everybody ready to take it up a notch? Okay. Flip the page. And actually flip to page 16, so 2 pages. All right. Now, sometimes you have things that are what are called compound units, like miles per hour, grams per milliliter, all right? Those are units where you have actually 2 units. You have one on top and one on bottom, okay? We're going to take a look at a couple of these and how to actually convert using these. So let's look at letter H. You have 60 miles per hour, and we are trying to convert that into meters per second. So if we do that, we're going to start like this. You're going to put 60 miles on top over 1 hour. Okay, 60 miles per hour. So that's 60 miles on top, 1 hour on the bottom. Now, in a case like this, you have 2 conversions going on. You have miles into meters that you're trying to do on top, and then you have hours into seconds that you're trying to do on the bottom. Okay? So, miles into meters, you probably don't know how many meters are in a mile. All right? Now, I will tell you that there are 0.62 kilometers, or I'm sorry, I flipped that around. There are 0.62 miles in a kilometer, and then you could convert kilometers into meters, all right? But I don't know specifically how many meters are in a mile. So that's what we'll go ahead and do. So right here, we want to convert miles into kilometers first. So what needs to be on the bottom? Kilometers or miles? You want miles down there because you want diagonal units to cancel. So you have 0.62 miles is equal to 1 kilometer. All right, and if we go from kilometers to meters, how many meters are in a kilometer? Let's go back to our King Henry. King Henry died by drinking chocolate milk. Here's meter. Meter's the base unit. Whoops. Meter's the base unit. Kilometers up here. So we're moving 1, 2, 3. So that's a factor of 10, 100, 1,000. So there's 1,000 meters in a kilometer. Now, what's going to go on the bottom here? Should be kilometers, okay? So 1 kilometer is equal to 1,000 meters. All right, and that gets us to where we need to be on the top. So kilometers cancels, miles cancels, and leaves us with meters per hour. We want meters per second, so we're not finished yet. Now we need to convert the bottom, okay? So on the bottom, you got 1 hour. We're trying to convert that into seconds. So let's go into minutes first and then minutes into seconds. So if we go from hours into minutes, what do we want on top right here? Hours is on bottom right here. So what do we want on top right here? We want hours because we want hours to cancel out. So 1 hour is equal to 60 minutes. That's the thing that's a little different about these compound conversions is now we are converting a unit that's on the bottom of that fraction. So hours will cancel and leave us with minutes. So we have meters per minute right now, but we want meters per second. So we have one last conversion. We go from minutes to seconds. And what goes on top right here? Minutes. So 1 minute is equal to 60 seconds. And there we're done. So minutes cancels out and leaves you with meters per second, which is what we want. So let's just go ahead and do our math here. So I'll point this out as we go along. So we have 60 times 1 times 1,000 times 1 times 1 divided by 1, and then divide that by 0.62, divide by 1, divide that by 60, and then divide that again by 60. All right, and so we end up with 26.88172043 meters per second. And when you round this only has 1 sig fig. So technically, we should round this to 1 sig fig also, which would be the very first number, which is a 2. Next digit 6 will round up to, actually, it'll round the 2 up to a 3 and make this 30 meters per second. Okay? Because you're rounding it to 1 sig fig. Here, I'll zoom out. Hopefully that'll make it a little easier. No, that's as much as I can zoom out. All right, you want to do one more of these? The compound conversions? I was going to do one more whether you wanted to or not. So, all right. Let's go and do letter J. No, let's do letter M. Letter M. All right, so letter M, we have 88 inches per second into miles per day. So you're going to start with 88 inches. And that's going to be per second. So over 1 second. 88 inches over 1 second. All right. Now, we are going from inches into miles, okay? So what we can do here, anybody know how many inches are in a mile? I'll be very impressed if anybody does. So probably not, but you may know how many feet are in a mile, and hopefully you know how many inches are in a foot. So we have 88 inches. The next conversion I would do would be inches into feet. So we would want inches on the bottom right here. So 12 inches is equal to 1 foot. Inches will cancel out, leave you with feet. And then anybody know how many feet are in a mile? Aiden? Nah, it's more than that.
It's like 5,650.
Closer. It's 5,280. Okay? So we want feet on bottom here. So 5,280 feet in 1 mile. Feet will cancel out. And that leaves us with miles per second. Well, we want miles per day. So we need to convert seconds into days. Okay, down here on the bottom. So we can go from seconds to minutes. So we want seconds on top right here. So 60 seconds is 1 minute. And then go from minutes to hours. So 60 minutes is equal to 1 hour. And then lastly, hours into days. So 24 hours is equal to 1 day. And that's your conversion. So seconds right here cancels with the seconds over here. Minutes cancels with minutes. Hours cancels with hours and leaves you with days. Okay? So go ahead and do your math right here. We have 88 times 60. Well, times the 1, times the 1. That's not going to change the value. Times 60 again. Times 24. And then we divide that by 1. Divide that by 12. Divide that by 5,280. And then divide by 1, divide by 1, divide by 1. Okay? Which ends up giving you 120. All right? Exactly. And that is miles per day. Those are the only 2 units you didn't cancel out. Miles right here, days right here. So 120 miles per day. And that is your final answer.